Hi there, and welcome to Scientific Adventures of Beardman, as we're looking today at how to turn the proportions that we've been dealing with into equations. What is an equation? Well, essentially it's a shorthand way of saying a whole bunch of stuff. So the first symbol that we need to know in order to say a whole bunch of stuff without writing a lot is the symbol alpha. Okay, alpha is a symbol that essentially means is directly proportional to. So whenever you see that in an equation, you would say to yourself, is directly proportional to. Just like if you see this symbol, you say is equal to. Okay, so is directly proportional to. Now, how does that relate to equals? Well, basically, if one thing, let's just talk about what we did in direct proportionality. Distance is directly proportional to time. That means as the distance gets bigger, the time gets bigger, the time it takes to travel there. So if we travel twice as far, it's going to take us twice as much time to get there. Or you could do it the other way. If we take 3 times as much time to go in the car, we're going to go 3 times as far. Okay, so now how can we write that? Well, any proportionality you could essentially write as the distance equals some constant times the time. Okay, so we'll have some sort of a constant in there. That's essentially what we're saying. So in other words, we're not quite at an equation, we're at a proportionality, and we'll be able to get there. We'll have to have some idea of what things we have to keep constant in order to build that. All right. The next thing is, how do we write inversely proportional? Well, we write it as something is directly proportional to the inverse of a value. So here's what that would look like. Okay, so here what I've actually written is v, or velocity, speed, is directly proportional to the inverse of the time. Now what we tend to say is v is inversely proportional to time. So now I've got 2 relationships here that we've looked at. If we spend more time traveling, then we're going to go farther. And if we go faster, increase our speed, well, that's going to decrease the amount of time it takes to get somewhere. Okay? So we have 2 relationships here, and they're tied together. We know that if we're going to travel for a certain amount of time and we go a certain distance and see those affecting each other, that's going to be based on the speed being constant. We see the same thing down here. We're going to double the speed and expect to get there in half the time. Well, we'd better be keeping the distance constant. Okay, so these 2 tie into a single equation. And we could write it like this. If the distance and time are directly proportional, we'd have to put those both in the numerator or both in the denominator, because that way when one increases, the other one has to increase. And here we see the inverse proportionality. The time we already have in this equation. Okay, and so if we want to put the velocity in, well, the velocity has to be in the opposite position. If t is in the numerator on one side, the velocity would have to be in the denominator on the other side. Because that way, if v gets bigger, well, we're dividing by a bigger number, so t gets smaller. That's inversely proportional. Okay? If t was in the denominator, then v would have to be in the numerator. Okay, so we can take these 2 equations and combine, or 2 proportionalities, and combine them to get one equation. Okay? And for this particular equation, those are the only things that we have to keep constant. In order to see this, we have to keep the velocity constant, so that would be our constant if we're looking at the relationship between these 2 things. And if we want to see how the velocity affects the amount of time it takes to get somewhere, then we'd keep the distance constant and would see that inverse relationship. Okay, thanks for joining us on Scientific Adventures of Beardman.